So how's the sound? Hey, getting ready to start here. Just getting some stuff out of the way. Okay, counting down. Let's see. Today I thought I'd try and double things up because I've had some questions about the servos on a couple different boards. So I thought I'd record some tutorials while I actually address it. So if you do have questions, put them in the chat. For a couple minutes, I'm just going to be doing the actual tutorial. And then we'll go back and see what questions we've got. So this is going to be a real simple one. It's just how to add a second servo to your configuration. So what I'm going to do is basically start off like I'm doing a tutorial so I can cut it out and use it as an actual tutorial. So I might make some mistakes, but you'll see how it works. So let me get things set up here to roll and make sure I've got everything organized. Okay. So today we're going to talk about how to install a second servo on the SKR version 1.4 for Big Tree Tech. Now I need to review a couple of things because we're going to do this slightly different. Normally we have a servo port down in here that we would use for our first servo, but there's no second servo allocated. So the ports that we can choose from, we have our X minimum, our Y minimum, our Z minimum. Then we have our filament detect for our first one and our second, and then we have our power detect. These are going to be important in a moment because the pins inside we have voltage, ground, and then signal. And that's going to relate to our actual servo over here, where the yellow or orange wire is signal. The one in the center, which is kind of orange or red, is going to be our voltage. And the brown one on this servo is actually going to be ground. So I'm currently in the position where I can USB power the board. So to hook this up, we're going to have to check the diagram to understand what's going on the Big Tree Tech website. So what I'm going to do is I'm going to bring up the actual diagram so you can see it here. And what we've got here is the Big Tree Tech SKR version 1.4 pinout diagram. It's on the GitHub page right here. So what I'm going to do is actually look down through here and see what we have. So we have our servo pins right here. And as you can see, they're ground, power, that's voltage, and then we have our pin number for signal. So in this case, I want to use the power detect pin over here. And the power detect pin obviously is going to be 5 volts, ground, and then signal. So we have to hook that up. So we're going to go back over to the workbench for a second. And I'm going to connect these wires that I have right here. Now as you can see, I have orange, gray, and red. So we're going to hook those up on the power detect. So I'm going to start with the actual voltage pin right here. And I'm going to slide that in. Then the next one's ground, so I have to hook that one up as well. So I'm going to take this one and slide it in and connect it here. And then finally we have our signal pin. So I'm going to connect it right here. And that one's the orange one. So we're going to pick up the cable, and as you can see, we're going to try and line up the colors as best we can. So orange to orange. Then we're going to do the voltage. And then we're going to do the ground. And so we've lined them up as best we can by color and what they are. So I'm going to push that off to the side. Now we're going to have to program it. So I'm going to connect the cable. There is a TFT drive already installed. So we're going to go over to VS Code for a second. And inside VS Code, we're going to have to load the firmware that I downloaded and extracted from Marlin. Now currently the version is 2.0.9.1. Obviously in the future it will change, so keep that in mind. So what we're going to need to do is actually click on the Explorer, then open folder. Then we're going to have to go to our downloads folder, the Marlin folder that I've extracted, the next Marlin folder that I have inside here, and then select the folder. Once that's selected, what we need to do is actually figure out a couple of things. Obviously our default environment is the Mega 2560, which we'll need to sort out. So I'm going to go to Marlin, Source, Core, Boards.h, and I'm going to search on the SKR underscore, and that'll bring us down to the turbo in here. Now here's our default environment of the chipset being LPC 1769. That's going to be important in a moment. So we're going to copy first the motherboard. Then we're going to close out of boards.h. We're going to minimize core. And we're going to go to configuration.h. We're going to search on motherboard and configuration.h. We're going to paste our board there. Then on the serial port, we need to change this to -1. And now comes the interesting part. We need to set up the actual servos. So I'm going to search on num underscore serv, and that'll bring us to number of servos. Now you can see that it's 3 right now. Technically you could probably do 3, but there's going to be some things you'll have to edit in the compilation where you'll see errors on the 3rd extruder. I'm going to skip that for now and just do 2. But when we do 2, that means we need to add an extra delay of 300 milliseconds. So now that that's done, there's no way to choose a second servo at the moment because we don't have one. So we're going to have to go over to pins. Then we're going to have to find our board type, which is the LPC 1769. Then we're going to have to search in here for our actual board, which is pins underscore BTT SKR underscore V1 underscore 4 underscore turbo. So I'm going to click on that. And what it says right here is that we're going to need to use the actual pins for that from the LPC 1768 for the Big Tree Tech SKR 1.4. So we're going to have to close that, go to LPC 1768, find the board, which is right here, and then what we're going to need to do is actually find the servo pin. Now, as you can see, there's only one specified, so we're going to have to copy this and then paste the second one down below it. And then we're going to need to change the servo number from 0 to 1. So over here, though, the pin that we found when we looked at the diagram being, I'll bring this up so you can see it, is right here. So it's 1.0. So now that we know that, we can go back over to VS Code. And inside VS Code, what we're going to need to do is change this number right here from P2 to P1. And that'll specify a second servo for us. Now we need to set up the compile. So I'm going to go over to the INI folder. I'm going to then find the LPC 1760X, and I'm going to find our chipset, which is the LPC 1769, and copy that. Then I'm going to minimize the INI and the Marlin folder, and I'm going to go over to platformio.ini and paste it right here. Now let's see what happens when we actually do a clean first to get the old build out if there is one. And now we're going to do an upload with the right arrow. That will build and then upload our build to our board. So I'm going to click on that. And if you see an error on the first compile, it may mean that something in the compile is building out of order. So try a second build first. And if you do realize that it's still not building, find the very first error that occurs and fix that. So this looks like it actually compiled and uploaded. So I'm going to bring up the folder for the drive, and what it says right here is firmware.bin. So what we know from that is that the actual firmware did just upload at 6:11 today. So we can actually go over to our desk and we can remove the actual drive for a second, plug it back in, and it will load the firmware. Then we can go over to Pronterface, and inside Pronterface what we can do is actually see if we can connect to it. But unfortunately our COM port is COM port 1, so we need to figure out what that is. In order to do that, we're going to have to actually go back over to our desktop and bring up Device Manager. And inside Device Manager, we're going to go to the COM ports. And as you can see, it says the COM port for it is actually COM port 7, because this one is default to the computer. So I'm going to close this. I'm going to click over here in Pronterface. And I'm going to change the 1 to a 7 and then connect. So now it says printer is now online. So the next issue that we're going to have is actually how to deal with the actual G code we need to test this. So I'm going to bring up the actual G code right here. So hopefully I can back into it, or I'll just type Marlin. And inside Marlin, we can go to Help. Then we can go to G codes and then All Documents. Inside here, I already know what the G code is for servos, but I'm going to try searching on servo. And as you can see, it brings us to the actual G code, which is M280. So the instructions are M280 is the command for servo position. Then we have P index. Then we have S position. So this is an angle, and this is an index number. So it's either going to be 0, which it normally is, or in this case, because we have a second servo, it's going to be 1. So what I'm going to do is then go back over to Pronterface, and inside Pronterface, I'm going to type M280 then I'm going to say P, and that's going to be our index, in this case 1, and then the angle we'll say for S, then we'll say 45 degrees, and I'll press enter. So apparently it didn't work, so what we need to do is figure out why. So let me go over and examine what the configuration is over here. And it looks like everything is correct, but maybe it's not seated correctly. So I'm just going to wiggle things around here, and I'm going to try that again. But what I'm going to do is try and move this back to 0 position. So apparently it's not working all of a sudden. So I need to examine closely what I've done here. It may be that one of the pins is not in position. So I'm going to power this down for a second. Okay, and let's see. Let's try reconnecting. Not sure how well this is going to work. There we go. So there was a loose cord. So if you like my tutorial, please press the like button and subscribe, and thank you for your time. Well, that didn't go well. What's the servo used for? It can be used for a bunch of other things. Servos sometimes are used for sleds, or they could be used for other devices. I don't know all the examples, but sometimes you can modify this board and use the Marlin firmware to make something like a robot to do other things. But the servos are present. The issue is, if you're working with servos, normally it would be a sled that deploys your BL Touch. But BL Touch uses the first servo port, so a lot of people have been asking how to get a second one so they can do that. So that would be one of the uses in this case. I actually think the old ramps configuration had 4, and one of the uses I thought would be useful was to create a bed leveling scenario where you use the servos to level the bed. But so far that doesn't seem feasible at the moment. So I'm going to show you what happens with the actual errors that you can encounter when you actually look for more servos. So over here you'll see that if I add a third servo, weird things happen. So down here, if I go and I say a third servo and then compile, adding one more of these, or actually I'll leave that out so you can see the arrow, or error. Excuse me. So when I first learned how to do this, one of the issues I ran into was this, where it didn't know what was going on with the servo. So let's see if I can recreate this error actually with 2 and take that out. So I'm going to change this actually to 1. I want to see that one arrow or error that I once saw. So I'm going to click the checkbox and see if there's an error on this. There shouldn't be, but I'm going to try a second one in a second. So if I go over here, it looks like it worked. Now we'll do 2 and then build it again. There might be an error that occurs here. And basically the error that I'm worried about is this. So what you need to do in this case is actually put comma 300 because it needs its own timing. And then you can build again. And that should work. Yeah, it would be an interesting thought. I think it's a great way to actually level your surface. So when you do 3, you got to do the same thing again, but there's going to be a new error that occurs. And this has recently been added because this was not an error years ago. So if I do this again, there's going to be a new error. One, I don't have a third servo, so we can add one in. But we'll see that in a second as yellow warning messages. Or maybe not. So I didn't see a warning message. We should see one. It's really odd, so I'm going to do a clean and I'm going to do a rebuild. There should be an error that occurs, but maybe it's just me, or maybe I just saw it that way last night. So apparently it's working today. So it should error out when there isn't a third servo. I don't know why it's working, but if you go over to source core, or excuse me, source pins, LPC 1768, then go to the SKR. If we were to take this out, we should see an error. Or a warning message. Apparently we don't. I don't know why, but okay. So I guess it lets you compile with multiple servos, even though you don't specify them, but it doesn't know what to turn. So that's how you get your actual servo to work, is by adding one. So does anybody have any questions today? Comments? Concerns? Okay, I guess it's a quiet audience so far today, but it is still early. So if you wanted to add a third, basically you have to re-enumerate. So you're going to give it another number, and then you're going to grab a pin number. So I'm going to copy this again and see if we can get away with another servo. I don't know how well this is going to work, but we don't know what the pin number is, so let's first change the servo number. And then what I'm going to do is I'm going to have to look at the diagram. So let me see where I am here. Apparently you can't see what I'm doing. That's awesome. Sorry, this is what I was talking about. Sometimes when I switch my screens, they don't switch when I don't switch them. So let me see if I can make this better so I can put it in a studio mode. There we go. So what we want to do right now is go back over to the desktop. We're going to find another pin. And we're going to use this one here, which is 1.25 for our third servo. So I'm going to bring up VS Code, and we're going to add a third servo. So it's going to be P1, and this is going to be 25. And that's going to be the configuration that we're going to use for the third servo. So let's double check, see what it says here. We're good. So let's build and upload it. I'm going to disconnect from Pronterface while that's going on. And I'll check on the chat while that's building. Okay, it looks like it built. So let's go back over to the board for a second and make the mods. So if we're on the actual workbench over here, I'm going to power this down, and I'm just going to move these over. So now we're on the actual filament detect. So this will be our third servo in theory. So let me plug it back in, let the firmware load, and we'll test to see if it works. So we'll go back over to Pronterface. And inside Pronterface we'll reconnect. And we need to change this number over here from P1 to P2 now. And we're going to move it to 0. And that worked. So let's try moving it to 90. That worked too. So to bring it backwards, you can actually do -90. And that'll change the direction. But if you want to do something like this, we say 90. And then you bring it back 180. Maybe it'll go halfway. Apparently not. So it might be at its furthest point, but let me see. Apparently that's furthest point. So we're in the 0 position right here. Let me bring the camera back up. And I'll check on the chat real quick. I don't know if you want me to do a force servo. Yeah, if you had 4 pins and you knew an algorithm that you could configure, you could easily create a way to bed level with the feedback that you get from the sense pin on either the BL Touch or the 3D Touch or something else. And that feedback you could use to calibrate your surface by turning screws to tighten and loosen according to where you want it to be leveled. But I think it's a complex algorithm, but I'm not sure. And then you'd reprobe to see how level it is. But I'm not going to program that because it looks like a nightmare to me. So maybe we can try a 4th pin. So we're going to actually go back over to VS Code and see if we can do that. So inside VS Code, what we can do is we can say, okay, we're going to have a force servo, and we're going to add another delay. So there's 300. I don't know if we can go to a 5th. It may not allow it, but we're going to have to go back over to the pins file. We're going to have to copy this again, paste it, increment the number, and then we need to find a pin, so we'll use DT1. So I'm going to go over to DT1, and it's 1.26, and I'll show you what I'm doing. Right here you see 1.26, so that pin is going to be inside VS Code. Don't know if the transition worked. Let me try that again. Apparently my OBS is not cooperating too well today. Was talking about this pin right here. So inside VS Code, what we're going to do is we're going to change the P1_26. So we'll go back over and see if we can actually compile this. And if this works, we'll go back over to our workbench and see if we can configure it correctly. Okay. So I'm gonna go back over to the workbench so you can see. I'm gonna disconnect the power. I'm gonna take the pins out again, align them best I can, and drop them in over here. and then we'll try it again in Pronterface. So inside Pronterface, we'll disconnect, reconnect. Well, first we got to connect the actual USB. Now we'll connect. Printer is now online, so we'll do P3 S45 and press enter. And now it says Servo 3 is out of range. So apparently there's something going on where it's limiting it to 3 servos, even though I know it can handle 4 most of the time. So that's interesting. And I'll show you why I think that. They may have it specialized to the actual particular board, but if you go over to the ramps board, and then you find the ramps, which probably says ramps. That's the 1.3. We want the newest one, which is right here. If you look on servo, you'll see why I think there's 4. So you got 1, 2, 3, 4 servos. So let's see if I made a mistake someplace. So doesn't look like I made a mistake. The reason that you see the defines, those are compiler directives for the if-end defines. And what it's trying to say is, if it's this, use this. If it's not, use this. And in this case, it's not a ramps 1.3 that I'm talking about. It's actually a 1.4, but they point back to the 1.3 for some of the pins probably. So that's why this looks all funky. But it's just a way to tell the compiler what to do. So let me go back to the chat and see if there's any questions here. Let's see, no questions so far. Okay, well, is there something else you guys want to see? Because I can't go any higher with the servos at the moment on this board. Now the process is similar, but on other boards it's different. Did you upload the new firmware? I probably did. We can try it again. That might be the issue. So what he's talking about, which I'll see if I can show you what I'm doing. So if I go over to my desktop, we can see the drive. And inside here, what may have happened is I forgot to actually upload the software, but it's 6:23, so that's about 8 minutes ago, so it's probably the case. So if I go over to VS Code and I do an upload again, in theory, it'll fix this problem. So the out of range was that I didn't upload the newest software, is what he's trying to point out. So let's go over to the workbench. I'm going to pull this, plug it back in. We're going to reconnect into Pronterface and see if that fixes the problem. So disconnect, reconnect. Let's try moving it. Okay, it might be a bad connection, so let me check that. Okay, let's take these out for a second. Voltage. Ground. And signal. I'm using jumper wires, so they're not the best to work with. So let's plug this back in. Disconnect, reconnect. Try this again. There we go. So it was a bad wire connection. So it does work. Maybe we can try 4 now. So we got to find a free pin, and I'll show you what we're going to do that's interesting with this. So if we go over to the desktop for a second, I'll pull up the actual diagram. So we're going to find a free pin around here to actually use for it. So we need to find a numerated pin that's not one of these, because they might be reserved. So let's look around and see. Looks like we've got 5 volts in ground here if we wanted to move over to those for jumpers. But we're already using this for the probe. So let's try using this from I2C, the 0.1. This at least will be a good example. So if I go over to the board, I'll show you what I'm about to do. So on the board, I'm going to take out the power for a second, and I'm just going to pull the signal pin. And the signal pin I'm going to find, let's see what the number is here. It's this one over here. I hope. There we go. So let's go over and configure this and see if we can get away with it. So we're going to add a 5th one. And the whole point of this is to actually show you signal pins, by the way. And the rationale behind it is to show you that all you need to know is what the signal pin is. So let me see what we got here. It's P0, and that's going to be 0.1, I believe. So we've got that set. We need to increment the number. Then we're going to need to go over to Pronterface for 2 seconds and disconnect. Then we'll go back over to VS Code and we'll do an upload. But that's not going to do us any good because I forgot to set a 5th one. So we'll check to see if something else works in a second. So comma 300. And it says there's no upload port because it's disconnected. So good thing is we didn't upload. So let me take us back over there. I'm going to plug this back in. Then I'm going to go back over to the actual VS Code. I'm going to do an upload again, and we'll watch the drive as it's occurring. So it looks like we got some errors. So let's see what we got here. So I guess we maxed out on servos because apparently it thinks the SKR board can't support more than 4 servos. That's based on RAMP's architecture, by the way. So the RAMP's 1.4 had 4 servos. So I guess they limit you to 4. So we got the answer there to why that doesn't work. Let's see. Title of the stream, Q&A Friday. Yeah, I think I tried to update that. Let me check to see what it looks like here. So I'll show you what it looks like so you have an idea of what's going on. So I was updating it the moment I started the stream, so it kind of didn't take the actual change. So that's why you're seeing the wrong thing occur. Let's see if I can fix this. So does anybody have any questions or comments of what they want to see? Okay, well, I guess we'll cut it short today. I'm gonna have to re-record the tutorial because it didn't come out right for me. I made obviously a mistake you guys might not have realized. That, and I forgot to hit record on the actual local copy. So I need to do it a third time. But if you have some questions, now's a good time to ask them. And we'll see if we can address them. I might even be able to show you how to do it on the other board. But more a question about octopus. What's the question about octopus? I have an issues to make USB-A port available. Not exactly sure how to do it yet, but I'm guessing it involves jumpers. Let me see if I can see the board. So here's the board. Let me power things down here. So I only have one of this board. And I'll get this out of the way in a second. If you haven't noticed, I have to use something to stick everything to the table, otherwise it moves around on me. And anybody that works in a museum knows what I'm using, so. It's also good for building model airplanes, but you didn't hear that from me. Okay, almost ready. I'm just cleaning up my modeler stuff here. Sometimes when it's warm like today, it doesn't want to come off as quickly. But there's the board. Let me see what you're seeing. Okay. So here's the octopus board. There's a USB up on top, and then there's a second one down below. You're asking how to make that work for using a file, I'm guessing. So let me actually move this over so you can see, because apparently I forgot. So down here is the second USB and then the first, second. So I think he's saying USB-A. So let me check on the chat to make sure I know what I'm saying here. I'm not sure if it's an issue with the board or with Marlin. So how about a future Friday making a display work with Clipper? Some of the displays work for Clipper. One of them that does work, I think, is the RepRap Full Graphics Smart Controller. TFT displays don't work at the moment. That's because they possibly wired slightly different. I use USB-C for the connection to Octopus and PC. You were talking about USB-A port. Let me look up what USB-A port is just to make sure I know what I'm saying. Okay, so the regular USB port is what you're saying. So, on here, hang on, I gotta get my browser straight. Interesting. Apparently I moved the chat on myself somehow. There we go. Okay, the USB port has no function. So let's test it out. So one of the ways we can do that is actually mess around with the USB. So let me think of a couple of ways to do this. We could try and load firmware through it and see if that works. Or we could see if we can use a file on it. But the problem is it's probably going to go to the first drive that's on there. So that's going to be interesting. So let's try taking out the USB card. And let me see if I've actually got a USB drive. Okay, it looks like I've got a USB drive, but it's a modified one. So I'm going to pop this out. Forgot this one's not spring-loaded. And I'm going to place it in here, if I remember how to do this. And try and load firmware on via this. So let me plug it into the computer and see if this works. Okay, so let's go over and set up Pronterface real quick. So let me check, see where we are. I gotta close out of here for a second because I'm gonna start from scratch. I'm gonna delete this. And you can't see what I'm doing. I'm gonna right click, extract all. Now the only problem that we might have with this is powering it. But we're going to use a USB-C that's run on power to actually power it. Which is the same as the other drive. But we'll make something different in the configuration so we can see what's going on. So now that that's extracted, we can go to VS Code. Inside VS Code, gonna make this so you can see. Gonna open the folder, downloads, Marlin, select folder, go back to the regular view for VS Code, and then I'm gonna go to, let's see, Marlin, source, core, boards.h, octopus. We're going to grab the 1.1 version, close out of here, note where we are for the chipset, which is STM32F44. So minimize, configuration.h, search on motherboard, paste, go up here and change this to -1. And then of course we have 3 ports. I don't know if anything's gonna be relevant for USB, but this might be. But it also says something down below about enable Bluetooth serial interface, which has nothing to do with USB in this case. So that's good. So we're gonna change something with the end steps. And the reason I do this is because then I know there's a known change. So I'm going to invert the actual Y end step to true. So it's going to say open, even though there's no end step actually configured. So let's go to the platform INI, go to the INI folder, STM32F4. And then we're going to look for the octopus again. Grab the first one we come across. Now there is one for V1 USB. So these are the same chipsets. So we could try that, but it says flash drive support. So let's copy that. Then we'll go up to platform INI, put in the default environment, and we got to build it separately. So I'm going to clean first. Then I'm going to do the checkbox for build because we can't directly load to it. And I've got a secondary USB here, but we got an error. So I'm guessing this has to do with what I picked, being the USB. Let's see what we got here. Not exactly sure what the error is, so let's click here. See if there's any comments around it. MSC endpoints. I'm not sure what that means, but there's something about USB up here. But I'm not getting a good answer as to what that is. It's kind of hard to guess right off the top of my head, but it might have something to do with our configuration. So let's go back and just take that out. So just backspace this off. We'll just build it for now after we do a clean. Hopefully I didn't click on upload. Now I'll check on the chat because obviously I've been distracted for a second here. Yeah, the USB flash drive support in advanced, we can try that next. Looks like I caused myself an error here. Let's see. Probably trying to upload. So let's go back and check to see what I did real quick. Apparently I'm getting a little tangential. No, that's correct. So let's go over to the advanced in a second. Let's try a build real quick. While that's building, I'll check for advanced. And we'll search on USB. Support for USB thumb drives using Arduino USB host shield or the equivalent Max 3421E breakout board. The thumb drive board will appear to Marlin as an SD card. Okay, so to do this, we can remove the comment with the Control/. I don't think we're using a shield, but we'll find out what happens. Native USB support by some boards. Interesting. So let's see what we got here. UHS2 uses no interrupts and has been production tested on the LUT spot to US or UHS 3 is newer with code better compatibility, but it's less tested and known to the interface with servos. So let's try native. Then we'll rebuild this. Obviously, I'm going to have to load it through the other port first. Okay, so to load this, we're going to go to .pio, octopus, firmware.bin, reveal in file explorer, right click, we're going to send it to the D drive, which is here. Okay, then we're going to go back over to the board. Check on the camera real quick here. I'm going to pop the drive out, and we're first going to load it over here. And let me bring some power to it. Just going to flash it for a second. And then we're going to try a second one, but we'll turn on printer face so we can see what's going on. Inside here I obviously need to check for device because it's changed. So it's not showing up as a device. That's because I'm in the wrong USB port. So give me a second. There we go. It's 9. Change this to 9. Try connecting. It's now online. So now we got to figure out if there's a G code for this. So we're going to go over to the browser for a second. G codes, whoops. And we'll search on USB. Okay, there's no functionality there. Drive. Okay, apparently I don't know of a G code unless I passed it and don't know it. There used to be one here, it's SD maybe? M27. Requires SD support, so that's not going to work. So we might have to turn that on. Let's try M20. Requires SD support. So it looks like we're going to have to enable that. Let me check on the chat because obviously someone's going to be telling me something else. Define USB flash drive support. So let's see what we got over here. Oh. Okay, well let's see if we can flash it from here. Obviously I made a change. I'll show you what that change is so we can go back to my original thought on this. Let me bring this up. So inside here, one of my favorite commands if I can get it to work, is M119. I changed it so you could see that the Y says open. So now we're going to change it back. So we're going to go into VS Code, go to Configuration H, just hit Control Z, brings it back to what it was. We're going to compile it. And we're going to put this on a separate drive stick. So we're going to take the one out that's already in existence and just load it from the other one. So we'll go over to the desktop. Apparently studio mode is not working for me today. There we go. Pull this out for a second. I'm going to extract this and I'm going to put it inside here. Better yet, I'll put it in the other one. Now you see why I don't use this drive, because it takes me a second to figure out where things go. There we go. So back in VS Code, right click on the bin, reveal in File Explorer. Drive's not showing up, so that's not good. Looks like I need to use the other drive because this one doesn't work. Okay, this one should work. There we go. Now we can check on what's on here. And of course you can't see what I'm doing. Give me a second. There we go. So basically this drive wasn't showing up on that tiny one that I was using, and the drive kept popping out, so I had to switch to the other one that I normally use. So that's now on there. So I'm going to pop that out and see if we can load it through the other connection. And we know that the mod for this is actually different. So let's see what happens. Doesn't even look like it's powered. Now there might be a jumper involved with powering it, but I don't know what it is. But there's a little light here that should light up. So let's just check on Pronterface. I'm guessing it didn't work. Yeah, it didn't work. So Let's see if we can figure it out in the manual. Give me a second to bring it up here. This might take a second to load. Sorry, just stepped on Raspberry Pi wiring. Notice how they're aligning the pins, but you can't see them real well on this diagram. But it's 5 volts on the right, and they're not on the 5 volts pin there. So it's the yellow they're using for 5 volts. Anyways. So here's the pinouts. USB A doesn't really tell us much. Not even sure USB A works at this point. Okay, let's look around the website. So if we go to Wiki, maybe? Looks like there's nothing. So let's go to issues. Search on an issue USB. That's not the issue, but that's bad. This is probably serial port -1. Let's see. Apparently they're pointing out that they see diffs. They might be talking about power. Obviously I'm not going to mess with my board power-wise today. And I don't even see it. So looking on here, they're talking about the power light. I don't know what that has to do with the problem. But I have a funny feeling there's no power coming out. And I'm not sure exactly the easiest way to test this pin inside here. I have a tester, but I need to know where voltage is. And then I need a way to break it out, so I would need a cord that I plug into this and break out the wires. Let's see if we can do that. I want to see if there's power on it. I know this seems silly. So I'm taking a power cord that's USB, and all I'm doing is, there's probably no power going through it on the board, and it may be powered by the power supply. So I'm going to actually cut this cable up and see if we can get something out of it. So there's shielded cables in here, so I'm going to have to peel them back. Because what I'm trying to get out of here, and I probably shouldn't do it over my board in case I drop something. So this one should be actual power. This should be ground. So let me clean this up a little. Just want to make it safer. I'm gonna probably have to put some electrical tape on this because it's not super safe right now. But I've taken off the wires. I'm going to do a wire stripper in a second for... Oops, that's a little sharp. So there's the exposed wire. So we're going to plug this in. We're going to take a multimeter out. Let me move this over so you can see better. So there's one exposed wire and its voltage. So I'm going to take out a multimeter and see if I can see anything. So I'm going to take out the probes, put one on here, and one on here. So there's voltage going through it, but it's 4.76 volts. So I don't know if that's the issue with powering my USB. Maybe my USB takes more voltage. So let me see if I can find a different USB lying around. Or let's try the other one again. That's backwards. Apparently that one doesn't light up either. So there's something else going on. Not exactly sure what the setting is. It might be USB support. So let me check on the chat, because obviously I've been off on a tangent for a couple minutes. Let's see, my USB drive has a light. USB-A is not powered. Page 4, bullet point 14 in the manual, 15, not 14. It should be 2.5 watts at 500 milliamps. So let me look back at the manual right here. Supports print from SD card and print via USB OTGA using integrated USB port. So let's look up USB OTA. OTG, pardon me. On the go. Not sure if this is a remote device for like your phone. Let me check on the chat. Okay, let's go back to the Marlin webpage and see what we can find there. Okay, let's search for OTG. It's going to be on the advanced config probably. So that's OTG. Search on USB, I guess. Onboard custom cable. So that's for the LCD. So let's remove the comment. Custom cable. Paste it right there. Close that down. Clean. Build. Multi-volume. In a second I'll try that as well. Oh, up here you're saying it has to be on board? Let's see, on board. Use the SD drive on the controller board. So then the other one is use custom cable to access the SD as defined in the pins file. So let's see what happens with this first. So let's go back over the board and see if it works first. The camera might cut out in a second, so interesting, it didn't load. Oh, that was through the other one. Okay. See if this actually lights up. Okay, that didn't work. Let's plug it in, try again. Let's rebuild it. Yeah, that's not working either. So this is probably going to involve some research. I'm hoping that it has something to do with a jumper, but there's already power in here that I measured. So my guess right now is I'm not sure how it works yet. But seeing how I've been going at this for an hour and a half. No, it has to be onboard. Yeah, I know. SD connection onboard didn't work either for that particular port. We know there's power coming out of 4.7 volts. So I'm unsure at the moment. We're going to have to research this a little bit later. So I guess what we'll do is we'll try and do this Friday, see if I can get some more information. It's a little bit new to me. So Everyone, take care, be safe, and remember to get vaccinated or wear a mask. And I'll catch up with you next week. And for those that have been tipping, thank you very much. And everyone, be safe.